Okay, next one, let's look at example 3. The effects of alcohol. Alcohol has many effects on the body. One effect is a drop in body temperature. To study this effect, researchers give several different amount of alcohol to mice, then measure the change in each mouse's body temperature in the 15 minutes after taking the alcohol. Amount of alcohol is the explanatory variable, and change in body temperature is the outcome of the study, so it's response variable. And furthermore, unlike the first one, husband's IQ and wife's IQ, that is what? That is association. But these two variables, the amount of alcohol applied, and temperature dropped. Between X and Y, it's not an association. It's what? It's a causation. Or you say cause and effect relationship. If you apply more alcohol to mouth, then it has what? More body temperature dropped, okay? So this is cause and effect relationship, causation. Now next one. The relationship between height and weight. Are height and weight related? Answer is yes. Okay? And what is the relationship between height and weight? Okay? The relationship, okay? It is what? Association. And not what? Not causation. You cannot say a person is pretty tall, and then therefore he must be what? Very heavy. Okay? No. Nothing like that. Between height and weight, it's just association. It's not a causation. Okay? If yes, what is the relationship? Is the relationship strong? Okay? So what's the relationship? Well, the taller are expected to weigh more, and the shorter are expected to weigh less. Okay? If the relationship strong, no, it's not strong. Because some people, they are very tall, but they are skinny. Look like what? Look like a bamboo chopstick. On the other hand, I also find some people, they are short but big. We call them what? Chubby, right? Next one. Explore the relationship. There is no reason to view one or the other as explanatory variable. Okay? That means there's, for certain variable, like a husband's IQ and wife's IQ. This is just what? The relationship is just association. Okay? But like example 3, if you apply more alcohol, then you're going to see what? More body temperature dropped. This is causation. But this one is just what? Just association. Okay? Now, next one. Scatter plot and interpreting a scatter plot. The main idea of using a scatter plot, it's a simple way of visualizing data, okay? Scatter plot, they display the relationship between two quantitative. They display the relationship between two quantitative variables measured on the same individual. The values of one variable appear on the horizontal axis, and the values of the other variable appear on what? Vertical axis. Always plot the explanatory variable, if there is one, on the horizontal axis, the x-axis of a scatter plot. As a reminder, we usually call explanatory variable x and response variable y. If there is no explanatory response distinction, either variable can go on the horizontal axis. And what does that mean? Think about example 3. Okay, this is alcohol applied. The amount of alcohol applied. Okay, this is X. And what's Y? Temperature dropped. Okay, this is Y. This is cause and this is effect. Okay, so the cause, the explanatory variable, we put on what? Horizontal axis. And response variable, we denote it by Y, and we place it on what? Vertical axis. Because there is a cause and effect relationship. Okay? Now, on the other hand, what's the relationship between height and weight? It's just what? It's just association. Since it's just association, either one can be on what? Horizontal axis. You can either call height the x and put in horizontal axis, or you can call weight x, put in horizontal axis, because there is no distinction between what? Explanatory and response variable, okay? Between height and weight, there is just association. It's not a causation. So either one you can place in what? Horizontal axis, okay? Okay. As I mentioned before, when people give us a data set, we can describe the data set with graphs or with numbers, okay? So when we are given the bivariate data set, okay, when we are given the bivariate data set, to study the relationship between x and y, we begin with a scatter plot, okay? This is use graph to study the relationship. And this is a scatter plot, okay? This is a scatter plot. Now, describing relationship with numbers. If you want to give more detailed description, okay, you go for numbers. And the relationship between two variables can be summarized by what? By average x, average y. Standard deviation x, standard deviation y. And R. R is the correlation coefficient. correlation coefficient. Let me give you an example. The scatter plot below displays the test score, midterm and final, of 150 students in a STAT 270 class. Only score for students who took both the midterm and the final are recorded here, okay? So look at the picture. Well, what do you find in the picture? You find this is what? Football shape. Okay, it's football shape. And if you imagine you can fit the data set with a line, okay, with a line. Let's see. So you fit the data set with a line, and you find this line has what? Has a positive slope. Okay? Now, what is a positive slope? Let's look at the picture here. In a triangle, this is called what? This point is x1, y1. Say this point is x2, y2. 2 points will uniquely determine a line, okay? And the horizontal move, we call this is what? Run. And vertical move, we call this is rise. And slope is defined to be rise over run. In our example, you find the slope has a positive slope. That means as x increase, y also increase. Okay? Apply to our example. Whenever you see a student get a higher score on the midterm, you also expect this person get somewhat higher in the final. That's positive association. Okay? That's what we call positive association. So use this one example. Describe the overall pattern. When people give us bivariate data set and we want to describe the relationship between x and y, what we should look at in the graph, we should look at the overall pattern that include the form of the relationship. Form means what? Linear or nonlinear. Direction, it means positive or negative. Positive means large X are more related to large Y. Negative means large X are more related to small y, okay? And how strong is a relationship, okay? If you find the fitting line has a positive slope, then we call this is positive association. As you can see from the picture, when somebody get higher score on the midterm, it tend to get what? Higher score on the final as well, okay? Now, in general, what do we observe in a scatter plot? Answer, we look at the following, okay? First one, we look for the form of the relationship. When we say the form of the relationship, we mean it's a linear relationship or nonlinear relationship. Look at the first two pictures. You see football-shaped scatter plots. And when you see football-shaped scatter plot, this suggests there is a linear relationship between x and y. As you can imagine, you can fit the data set with a line, okay? This line has a positive slope, positive association. This one has a negative slope, negative what? Negative association, okay? Now, this picture, if you fit the data you cannot fit by a line. You fit with what? A curve. So in this case, the above scalar plot suggests that there is a nonlinear relationship, or you say what? You say curvilinear relationship, okay? We also look at the direction of the relationship, okay? Direction means positive association or negative association. The first one, when you see football-shaped scale plot, you know you can fit it by line. So linear or nonlinear. Second one, in the graph, you want to observe the direction of the relationship, okay? Positive association or negative association. Suppose this is what? The scalar plot. The fitted line has a positive slope. This one has a positive slope, okay? That means as x increase, y also increase. Positive association. For positive association, look at here, key observation. There are more observation in area 1 and 3 than those in area 2 and 4. Okay, let me redraw it so you can see better. We call this is x equal to average x. This is y equal to average y. And this point here is called the point of averages. Okay. This vertical line and this horizontal line will divide the football-shaped scalar plot into 4 different areas. 1, 2, 3, and 4. Okay, 4 different areas. But obviously you can see why it gives you an impression. It's a positive association. Because you see more observation in area 1 and 3 than those in 2 and 4. Okay? So the key observation. There are more observation in area 1 and 3 than those you find in area 2 and 4. Okay? Now, this is kind of important. Why I say that? Think about this. Say X is what? Husband's IQ. And Y is a wife's IQ. Okay? Look at the picture here. Look at the picture here. What do you find here? Those observations you find here, I call them large X. Why I call them large X? Because their X values are greater or equal to average X. So I call them large X. You see, large X are related to large Y's. Why I call them large Y's? Because those observations, their Y value, greater or equal to average Y's. Okay, let me try one more time. Large X are related to large Y's, but also related to small Y's. But large X are more related to large Y's. Why I say that? Because there are more observation in area 1 than those in area 4. Okay, so large X are more related to what? Large Y's. Let me try one more time. Large X are related to large Y's, but also related to small Y's. But large X are more related to large Y's. Put on our context, okay? Large X means smarter husbands. Smarter husbands marry smarter wives, but also marry dumber wives. But more smarter husbands marry what? Smarter wives. Okay? Now let's look at the other side. Look at the other side. These are I call what? Smaller y's, okay, smaller y's. Why is called them smaller y's? Because their y values are all less or equal to average y's, okay? Small y's are related to large y's, but also related to small y's. But small x are more related to smaller y's because more observation in area 3 than those in area 2. Put in our context, we say dumber husband marry smarter wives, but also marry what? Dumber wives. But more dumber husband marry what? Dumber wives. This is what we call positive association. Large X are more related to large Y's, and small x are more related to small y's. This is for positive association. How about negative association? Negative association, in contrast to the positive association, is large X are more related to what? Small y's. And small x are more related to large y's. Okay? Negative association. Large x are more related to small y's, and small x are more related to large y's, as you can see from the picture. For negative association, you have more observation in area 2 and 4 than those in 1 and 3. Okay?